I wanted to touch upon today one other topic in the business and economics application side of the house, but we didn't have too much time, so I wanted to go through it on video, and that's dealing with the cost function. The cost functions, denoted by C of x, usually has two components, a fixed cost and a variable cost. The fixed cost is independent of any number of items that you're working with, but a variable cost is going to depend on the number of items. So, by definition, your average cost function, let me grab another pen, your average cost function so the average cost function is going to be the cost function divided by x. And we'll see this in an example. The marginal cost function is an approximate cost of producing one additional item after producing x items. So it's actually C prime. All right, and again I'll write down it's the approximate cost of producing one additional item. So one more additional item after producing x items. So one additional item after producing x items. So that's what your marginal cost represents, and it's a derivative. It's the derivative of the cost function. Okay, so let's look at an example. I'm going to pause here. Okay, so here's the example. We have a cost function C of x defined as this on the interval 0 to 1500 with parameter a equals 1000. You'll see how that gets used in a minute. So your first task is to find the average cost and the marginal cost functions. So by our definitions, the average cost function is equal to the cost function divided by x. So take the definition of the cost function and literally divide each term through by x. So the average cost function is usually denoted with a bar on top. So the average cost function is equal to negative 0.01x plus 40 plus 100x. So all I did there was just separate off each one of these terms and divided it through by x. Okay? Whoop. I got a messy thing there. So that's your average cost function. So how do we find our marginal cost function? So your marginal cost function is a derivative. So your marginal cost is C prime x. C prime of x. And the derivative of that function of C of x is negative 0.02x plus 40. So that's your marginal cost function. Step 2 asked to determine the average cost and the marginal cost when x equals a, or x equals 1000. So you want to determine the average cost, which is C bar, and the marginal cost, C prime, when x equals a, which was given to be 1000. So the average cost, C bar of x, you're going to plug it into function. Okay, so that's 0.01 times 1000 plus 40 plus 1000, plus 100 over 1000. And the answer there is 30.1. We'll interpret them in a minute. And then the marginal cost, I guess I ran out of scrolling space. We're going to have to scroll over, page over. So that was the average cost. The marginal cost is C prime evaluated at 1,000. So this was negative 0.02 times 1,000 plus 40 equals 20. And your last step was to interpret the values that you found in step 2. So interpret the marginal cost and interpret the average cost. So the average cost, C bar of X, is the average cost per item. So when you're producing 1,000 items, the average cost per item is $30.10. So it's the average cost per item. So when you're producing, in this case, 1,000 items, the average cost per item is $30.10. So that's how you interpret the first. The first figure. The second one is marginal cost, which is a derivative. And the interpretation that is for producing the 1,001, okay, so one item past your nominal number of items that you're computing. So the marginal cost for producing the very next one, so in this case, the 1,001st item would be $20. Okay, from back up here, right, this was the marginal cost was 20, and that's how you interpret it. The marginal cost for producing the next item after your set production rate. So the next item is the 1,001 item would be $20. So that's that business application that we talked about, and that wraps up the 3 areas that I wanted to hit.